Hello students, today you have practice problems for section 10.1. You should have already completed these problems. Now you're checking them and make sure they're correct and doing any corrections you need to. In number 1 here, we want to go from 15.7 moles of CO2, and we want to figure out how many molecules we have. We start with 15.7 moles of CO2. For every mole of CO2, we're going to use Avogadro's number. We're going to use the 6.022 times 10 to the 23rd molecules of CO2 in 1 mole. Moles divide out moles. Now we take the 15.7 times the 6.022. Equals 94.54. We keep the 10 to the 23rd. Got to check our sig figs. We started out with 3. We want to keep 3. That would be those 3. And I want to adjust it to 9.45. I moved my decimal back 1, making this number smaller. It means I need to make the other one bigger. I make the exponent now 24 molecules of CO2. Number of molecules in, okay, so we're going from moles of H2O to molecules. So 0.0544 moles H2O times 6.022 times 10 to the 23rd molecules in 1 mole of H2O, molecules of H2O. Mole divide out moles. Once again we multiply, this time taking a coefficient 0.0544 times the 6.022, and we get 0.32759 for the first few digits times 10 to the 23rd. And adjust and make sure we got the right number of sig figs. Looks like I ought to keep 3 sig figs. That would be those 3, so I'm going to make this 3.28. I made this number bigger, moving my decimal 1 spot, so I make my exponent smaller by 1. 3.28 times 10 to the 22nd molecules of H2O. And number 3. This time we want to go from atoms to moles. So we start with the 9.22 times 10 to the 23rd atoms of iron, Fe. In 1 mole of iron, we have 6.022 times 10 to the 23rd atoms of iron. Atoms cancel atoms. This time we get to do, and I can also cancel the 23rds, drop clear out. So all I got to do is take the 9.22 divided by 6.022, and that gives us 1 point, and I get to keep 3 sig figs again, so 1.53 moles of iron. This time we're going to go from sucrose molecules to moles. So 2.05 times 10 to the 22nd. I'm just going to write SAM sucrose molecules. 1 mole of sucrose is 6.022 times 10 to the 23rd sucrose molecules. Sucrose molecules, divide out sucrose molecules. We take the 2.05 divided by the 6.022 gives us 0.3404. That's plenty of digits. Times 10 to the, this time we need to subtract the exponents, times 10 to the negative first. Yeah, because this is such a small exponent, rather than taking it into scientific notation, I think I'll just switch it out and put it in standard form, which would be 0.0, moving our decimal back one spot. And we get to keep 3 sig figs, so it's 3, 4, moles of sucrose. And our last one for this little part. This time says student used moles of copper to carry out a reaction. Reaction uses up how many formula units are left unreacted. So the first thing we have to do is take these and subtract to figure out how much is left over. And we subtract, we get 0.0018 moles of copper sulfate left over. Now I just want to change this to formula units. So we take our 0.0018 moles of copper sulfate and then 1 mole of copper sulfate. We have 6.022 times 10 to the 23rd units of copper sulfate, formula units. Moles, divide out moles. Take my 0.0018 times 6.022. And we get 0.01083996. Everything on my calculator. Times 10 to the 23rd. Yeah. Would make sense to do 2 sig figs because of that, but I'm going to go back to what we started with and use 3. The 3 would be here, so I'm going to change that to 1.08 times 10 to the, move my decimal twice, making this number bigger. I want to make this number smaller, so 21. Formula units of CuSO4. So a little bit of work with finding number of molecules, number of what we call representative particles. Other formula units, molecules, atoms. So should be able to handle all this stuff. And sure you can know how to do it as we get to a quiz and test. So that's it for now.